In Kerala's industrial zones, continuous manufacturing is threatened by severe voltage drops and sudden supply interruptions. When heavy machinery loses power, production grinds to a halt, costing facility owners both time and raw materials. The state's electrical board currently hits a production ceiling at roughly 2,898 megawatts. To meet daily demand beyond that limit, Kerala relies heavily on importing expensive, fossil fuel-generated power from outside its borders. The conventional approach to closing an industrial energy gap like this is to build a massive utility-scale solar plant capable of producing 1,688 megawatts. But building a centralized facility of that size requires an estimated 5,900 crore rupees and a staggering 8,440 acres of land. Kerala is densely populated and ecologically sensitive. Acquiring an uninterrupted stretch of land that large is physically impossible and politically unworkable. Knowing these geographic constraints, Father Dr. Abraham Mullamutil and the MSME Chamber submitted an entirely different proposal to the government: a zero-land architecture. Securing energy independence for the state means abandoning the idea of massive, centralized solar farms. The solution requires a decentralized, almost invisible power grid. Kerala already has the square footage required. It exists as unutilized real estate right above the factory floors, the rooftops of its 168,807 registered MSME units. If each registered factory installs an average 10-kilowatt solar system, the combined output reaches that exact 1,688 megawatt target. The state matches the output of an impossible megaplant without clearing a single new acre of land. Generating electricity directly on top of the facility that consumes it solves a major engineering problem. It virtually eliminates the typical 4 to 8% grid transmission loss, delivering power exactly where the load is highest. But raw solar power has an obvious limitation. Panels generate electricity during daylight, while industrial units draw heavy power loads during evening and night shifts. To bridge the timing gap, the proposal introduces a first layer of technological support: shared, cluster-level battery energy storage systems installed at the center of KINFRA industrial parks. This chart compares two battery chemistries. Left, lithium-ion offers high energy density for tight spaces. Right, sodium-ion. For shared banks, sodium-ion is crucial. Its higher thermal runaway threshold makes it safer in Kerala's hot industrial sheds. The solar panels act as the harvesters, but it is the strategic placement of these regional battery clusters that refines variable daylight into a firm 24-hour power supply. Battery storage handles the nightly shift, but it depletes within a few hours. It cannot sustain an industrial park through the severe, long, multi-day cloudy periods typical of a Kerala monsoon. For seasonal storage, excess midday solar power is diverted into localized electrolyzers. These units use surplus electricity to split water, producing green hydrogen. Stored hydrogen functions as a highly versatile industrial asset. It can be supplied directly to factories that require high-temperature chemical feedstock, or run back through stationary fuel cells to generate backup electricity when the battery banks are fully depleted. Building this three-layer infrastructure of solar, battery, and hydrogen requires significant capital. The average factory owner cannot absorb those heavy upfront costs alone. The consortium structured a financial model requiring only a 25% equity contribution, with a bank loan covering the rest. Because monthly energy savings exactly match the monthly loan repayment, the business experiences zero net cash outflow. The system pays its own debt. The blueprint delivers complex engineering, supported by a closed-loop financial structure that ensures widespread adoption is economically viable. To execute this, the state government does not have to build or manage the network. They only need to provide a 20% capital subsidy, drawing directly from their pre-existing state budget for renewable energy and green hydrogen. Deploying a targeted incentive spread over thousands of private businesses avoids the crippling 5,900 crore rupee capital expenditure the state would have faced building a centralized megaplant. The result is a fully realized industrial cluster, operating autonomously. The factories draw reliable power through the evening, completely isolated from external voltage drops and grid failures. As these localized hydrogen production nodes scale up, they will build the baseline storage inventory required to supply future state transportation systems, like the proposed K-Rail project. Kerala achieves energy independence not by acquiring thousands of acres of new land, but by leveraging the industrial rooftops it already has, empowering existing manufacturing centers to operate as a synchronized, self-powering grid.